So Newton-Raphson method. So let f of x equals 0 be the given equation. So we take the given equation as f of x, which is equal to 0. Now using this Newton-Raphson method, we can find the real root of the algebraic function f of x equals 0, and also we can find the real root of transcendental equations. So now what we will do here is by inspection method, first we find two values a and b such that they are in opposite in signs. That is, f of a is less than 0 means f of b should be greater than 0. So if f of a is less than 0 and f of b greater than 0, so one functional value is negative, that is less than 0, and another functional value is positive, greater than 0. So by inspection method, a real root lies in between a and b. So we start with an initial value x0. So x0 can be taken as either a, or x0 can also be equal to b, or any value in between a and b. x0 can be, we can take x0 as a, or x0 can be equal to b, or any value in between a and b. So we consider x0 to be the approximate root of the equation f of x equals 0, and we will start the iteration process. So by Newton-Raphson method, the formula to find the real root is given by xn plus 1 equals xn minus f of xn by f dash of xn, n equals 0, 1, 2, 3, etc. So this is the formula to find the real root by Newton-Raphson method, where f dash of xn stands for derivative of f of x. Now let us solve a problem. Find a real root by Newton-Raphson method for x cube plus x square plus 3x plus 4 equals 0. So take the equation as f of x. So f of x is x cube plus x square plus 3x plus 4 equals 0. Then go on giving values for x. First we have to locate where the root lies. So by inspection method, put x equals 0. So f of 0 is 4. 4 value is 4 is greater than 0. Now put x equals 1. So f of 1 is 1 plus 1 plus 3 plus 4, which is equal to 9, greater than 0. And put x equals 2. F of 2 is 8 plus 4 plus 6 plus 4 equals 22, greater than 0. So if we give positive values for x, like x equals 1, 2, 3, 4, 5, etc., each and every time we get functional value which is greater than 0. So always f of x will be greater than 0 for positive values of x. So now give negative values. So x equals minus 1. So f of minus 1 is minus 1 plus 1 minus 3 plus 4 equals plus 1. This is also greater than 0. Now put x equals minus 2. F of minus 2 is minus 8 plus 4 minus 6 plus 4. This is equal to minus 6 less than 0. So when x equals minus 1, we get plus 1, which is greater than 0. When x equals minus 2, f of minus 2 is minus 6 less than 0. So one value is greater than 0, another value is less than 0. So root lies in between minus 1 and minus 2. Now we have to choose x0 in between minus 1 and minus 2. So for minus 1, f of minus 1 is plus 1. And for minus 2, x equals minus 2, f of minus 2 is minus 6. So when you see plus 1 and minus 6, so plus 1 is closer to 0 when compared to minus 6. So you have to understand this. Plus 1 is closer to 0 when compared to minus 6. So take x0 as minus 1. So we will start the iteration process by taking x0 equals minus 1. So you can also take minus 2, but you have to do more number of steps in order to get the root. So if you take minus 1, you can get the root in less number of steps. So now, so in the formula, take the given function is x cube plus x square plus 3x plus 4, and f dash of x means derivative of f of x. So derivative of x cube is 3x square, derivative of x square 2x, derivative of 3x 3. And now, so by Newton-Raphson method we have xn plus 1 equals xn minus f of xn by f dash of xn. So in the denominator, f dash means it is derivative of f of x. So now first iteration, put n equals 0. So x1, so formula becomes, when you take n equals 0, formula becomes x1 equals x0 minus f of x0 by f dash of x0. So what is x0? So x0 we have taken minus 1 minus f of minus 1 by f dash of minus 1. So this is equal to minus 1 minus, so f of minus 1 is 1. So already we have calculated f of minus 1. F of minus 1 is 1, we have calculated. So f of minus 1 is 1 whole divided by f dash of minus 1. So f dash of minus 1 means you have to use this equation. So by using the calci, so f dash of minus 1 is, we get 4. So minus 1 minus 1 by 4 equals minus 1.25. So this is the root in the first iteration. Now we have to improve the accuracy of this root. Now in the second iteration, take n equals 1. So the formula becomes, when you take n equals 1, the formula becomes x2 equals x1 minus f of x1 by f dash of x1. So this is equal to x1 is minus 1.25 minus f of 1.25. So you have to use this equation. So f of minus 1.25, so we get, so using the calci, so minus 0.1406 whole divided by f dash of x1. F dash of x1 is f dash of minus 1.25. We get 5.1875. So this is equal to minus 1.229. Minus 1.229. So similarly, again, so you have to compare x1 and x2. So how many decimal places are same? After the decimal point, how many decimal places are same? So here only one decimal place is same. So 2 and 2. After the decimal point, there is only one decimal place is same, 2 and 2. Now we have to improve the accuracy. So now x3 equals, third iteration, take n equals 2. Formula becomes x3 equals x2 minus f of x2 by f dash of x2. So x2 is minus 1.229 minus f of x2. F of x2 we get minus 0.002 whole divided by f dash of x2, means f dash of minus 1.2229. We get 5.0407. So this is equal to minus 1.2225. So compare x2 and x3. So after the decimal point, 3 decimal places are same. So it is enough. So therefore, the required root is, so the required real root is minus 1.2225. So if you want to keep this root for 3 decimal places, so fourth place there is 5. So increase the third digit by 1. So we get minus 1.223 for 3 decimal places. So this is the required root. So now let us solve the next problem. Find a real root of the equation x into sin x plus cos x equals 0 near x0 equals pi. So here given function f of x is x into sin x plus cos x. find f dash of x. So that is in the formula we need f dash of xn. So find f dash of x. So x into sin x, apply product rule. X into derivative of sin x is cos x plus sin x into derivative of x is 1 minus derivative of cos x is minus sin x. So plus sin x minus sin x gets cancelled. So f dash of x is x into cos x. So here in this problem no need to give values for x like x equals 1, x equals 2, x equals 3, etc. as we did in the previous problem, because in the data it is already given that the root lies near x naught equals pi. So again I am repeating, no need to give values for x, no need to use inspection method here, no need to give values for x like x equals 1, 2, 3, etc. because in the data it is already given that the root lies near pi. So take x naught equals pi, that is root lies near x naught equals pi. So directly we will apply iteration process now to find the real root. Now by Newton-Raphson method we know the formula xn plus 1 equals xn minus f of xn by f dash of xn. So first iteration, put n equals 0, formula becomes x1 equals x naught minus f of x naught by f dash of x naught. So x naught is pi, so pi minus f of pi by f dash of pi. So this is equal to, so pi minus f of pi. So f of pi is pi into, f of pi is pi into sin pi plus cos pi. So we get minus 1 whole divided by f dash of pi. F dash of pi means pi into cos pi. So pi into cos pi is minus 3.1416. So this is equal to, so pi minus of minus plus, so 1 divided by minus, so minus of minus plus by minus, so that is we get minus. So after simplifying this by calci we get 2.8233. So this is the root in the first iteration. Now we have to improve the accuracy of the root. So in the second iteration, take n equals 1, formula becomes x2 equals x1 minus f of x1 by f dash of x1. So now x1 is 2.8233 minus f of 2.8233. So using this function f of x, so we get minus 0.0662 whole divided by f dash of 2.8233. So that is minus 2.6815. So this is equal to 2.7986. So this is the root in the second iteration. Now we have to improve the accuracy of the root again. So before that compare x1 and x2. So how many decimal places are same? So after the decimal point, no decimal places are same. So again we have to improve the accuracy. So in the third iteration, put n equals 2. So we get x3 equals x2 minus f of x2 by f dash of x2. So this is equal to, x2 is 2.7986 minus f of 2.7986 is minus 0.0006 whole divided by f dash of 2.7986. So we get minus 2.6356. So this is equal to 2.7984. So compare x2 and x3. Compare x2 and x3. So after the decimal points, 3 decimal places are same. 0.798 here, 0.798. So 3 decimal places are same. So that is enough. We can stop the iteration process here. So therefore the required root is, the required real root is 2.7984. So if you want to keep this for 3 decimal places, so this is approximately equal to 2.798. In the fourth place there is 4. 4 is less than 5. So no need to add 1 For the third digit, you can keep the number as it is. So it is 2.798. For correct root to 3 decimal places. So this is the required root. And now let us solve the next problem. Use Newton-Raphson method to find real root of x into log x to the base 10 equals 1.2. Correct to 4 decimal places. So this is a transcendental equation since the equation contains logarithmic function. So the previous problem also transcendental equation. So that is in the previous problem we solved x into sin x plus cos x equals 0. This is also a transcendental equation. So this equation contains trigonometric functions sin x and cos x. So here the calci mode should be in radians. You should remember that here while calculating the functional values, the calci mode should be in radians because this is a transcendental equation which contains trigonometric functions. So but here x into log x to the base 10 equals 1.2. This is also a transcendental equation. Here the equation contains logarithmic function log x to the base 10. Now given function, take the given function, given equation as f of x, that is x into log x to the base 10 equals, x into log x to the base 10 minus 1.2. So as usual, first find where the root lies. By inspection method, put x equals 1. F of 1 is 1 into log 1 to the base 10 minus 1.2, which is equal to minus 1.2 less than 0. Put x equals 2. F of 2 is minus 0.5979 less than 0. X equals 3. F of 3 is 0.2314 greater than 0. So for x equals 2, functional value is less than 0. For x equals 3, functional value is greater than 0. So by intermediate value property, root lies between 2 and 3. Root lies between 2 and 3. So now for x equals 2, f of 2 is minus 0.5979 less than 0. For x equals 3, f of 3 is 0.2314 greater than 0. So when you compare these two values, 0.2314 is very close to 0 when compared to minus 0.5979. 0.2314, this value is nearer to 0 when compared to minus 0.5979. So take x naught equals 3. So let us start the iteration process by taking x naught equals 3. So before starting the iteration process, we have to find f dash of x. So f of x equals x into log x to the base 10 minus 1.2. So now to find f dash of x, convert log x to the base 10 to log x to the base e. So this is very important. So before finding f dash of x, convert log x to the base 10 to log x to the base e. So f of x equals x into log x to the base 10 is nothing but 0.4343 into log x to the base e. So log x to the base 10 is equal to 0.4343 into log x to the base e. So x into 0.4343 into log x to the base e minus 1.2. So f of x equals 0.4343 is a constant into x into log x to the base e minus 1.2. Now find the derivative of f of x. So f dash of x is 0.4343 constant into, now apply the product rule. There are two functions. First function is x, second function is log x to the base e. So x into derivative of log x is 1 by x plus log x into derivative of x is 1. Derivative of 1.2 is 0. So f dash of x is 0.4343 into x gets cancelled. So the remaining terms are 1 plus log x to the base e. So by default the base is e here. So f dash of x is 0.4343 into 1 plus log x to the base e. Now we can start the iteration process. So by Newton-Raphson method, we know the formula xn plus 1 equals xn minus f of xn by f dash of xn. N varies from 0, 1, 2, 3 and so on. first iteration, take n equals 0, formula becomes x1 equals x naught minus f of x naught by f dash of x naught. So x naught we have taken 3, so 3 minus f of 3 by f dash of 3. So this is equal to 3 minus, so f of 3 is f of x. F of x is x into log x to the base 10 minus 1.2. F of 3 is 3 into log 3 to the base 10 minus 1.2. So we get 3 minus 0.2314 whole divided by f dash of 3. So f dash of x is 0.4343 into 1 plus log x to the base e. So f dash of 3 is 0.9114. So by using the calculation we get 2.7461. So this is the value of the root in the first iteration. So now we have to improve the accuracy of the root. Now take second iteration, take n equals 1, formula becomes x2 equals x1 minus f of x1 by f dash of x1. So x1 is 2.7461 minus f of 2.7461. So by using the calculation we get 0.0046 by f dash of 2.7461. We get 0.8730. So this is equal to 2.7408. So this is the value of the root in the second iteration. So now compare x1 and x2 values. So after the decimal point, how many decimal places are same? So 2 decimal places are same, that is 0.74, 0.74. So again we have to improve the accuracy of the root. Third iteration, take n equals 2, formula becomes x3 equals x2 minus f of x2 by f dash of x2. So x2 is 2.7408 minus f of x2. F of x2 means f of 2.7408. So substituting in f of x we get 0.0001 by f dash of 2.7408, f dash of 2.7408. So substituting in this equation f dash of x. So by using the calculation we get 0.8721. So after simplifying we get 2.7406. So compare x2 and x3. So how many decimal places are same? So 3 decimal places are same, so it is enough. So therefore required root is 2.7406. So we can keep this value for 3 decimal places. Correct to 3 decimal places it is 2.74. In the fourth place there is 6 is greater than 5. So add 1 to the previous digit, that is add 1 to the third digit, we get 2.741. So this is the root of the given equation for correct to 3 decimal places.